Hi there guys, just wanted to jump on and say welcome to video number 94. This video is on interpreting real life graphs. The keyword here is interpreting, and that just means understanding or making sense of. The method I've got for you states that there are a number of different graphs you could be asked to interpret in the world of maths. That's because graphs can be drawn about anything. The most likely questions are ones where you're going to need to find out the particular cost of something, or the speed of it, or how quickly something fills up. And to calculate those things, it's all the same thing. It's working out the gradient of the line, how steep the line is. And I've done a separate video on that. This is just using it in a contextual real life graph problem. All right. So we will get on with it, and I'll zoom into the first question. And you can have a look. Now the numbers are pretty difficult to see what they are, and you probably won't be able to see me write the answer of the last question, but yeah, I'll do my best to try and help you understand what's going on. So in first question, Fonzie is a taxi driver, and you can use this graph to work out the cost of a journey in Fonzie's taxi. And it's all dependent upon the number of miles travelled, which is n, and that would be the cost of the journey is dependent upon that. Now, what is the fixed cost? Well, let's look at the graph. Where does the graph start? The graph starts at exactly £5. So the fixed cost of the journey, as soon as you get into Fonzie's taxi, is costing you £5. All right. So I'll get the actual freehand tool and write the number 5 in the answer space that I've got there for question A, £5. Now, to work out how much it is per mile, what you need to do is find the gradient of the line. And that will give you the cost for every mile. All right, so I'm going to choose two clear points, and I can see that the graph goes through. We'll take this point 0,5. All right, the coordinate 0,5, and then we'll take this coordinate here, because I can see that it definitely goes through the point 1020. So there's our two coordinates, our two clear coordinates that are on the line. And then I'll get the line tool and I'll find the gradient. So you go from there to there and there to there, right? And we're looking for this difference here in between those numbers. So if we've got the difference between 20 and 5, we know that's 15. And we've got this difference between 10 and 0, which is 10, right? So all we do is we take the difference in the y and divide by the difference in the x, just like you would when you find the gradient of a line. And that is it. All right, so 15 divided by 10, you should know by now, is 1.5. But in context of money, we put the £1.50. All right, and that's what I've written underneath my face there. All right, so I'm going to zoom out of that one, and you'll see that. And then I'm going to zoom in to the second question. Now, this one, much harder to see on the scale with the numbers. I know it's really difficult. It's quite fuzzy. I'm sorry. But the graph shows the volume V of water in a pool at time t. V is measured in litres and t is measured in hours. Find the rate at which the water flows into the pool. So this pool is being filled up with water at a constant rate. All right, you can see that because the line is a straight line. All right, now let's first of all think about what the units of our answer is going to be. All right, we got t measured in hours and litres measured in, volume measured in litres. Time is the hours, and volume is litres, right? That is the units of our answer, or they are the combined units of our answer. All right, we're going to smash them together, compound units. So it's going to be litres per hour. So L/H half hour. All right, and that is the units. Now that most of the time will be provided for you, or they'll tell you what to do and state the units of your answer. There's my number. I'm going to put my number in this space here. And that's how many litres per hour it's going to be. So again, it's just finding the gradient of the line. Now take two clear points. I'm going to take the start of the line and the end of the line. All right, and I can see, because this scale is pretty difficult to navigate, we've got 80,000, 100,000, so that's 90,000 halfway there. And then each one of those is worth 2, so 92, 94, 96, 98, 100. So that is 94,000, that is 20,000. So what we need to do is find the difference between those, and I'll just draw the line on there again, which shows you what we're doing. We're finding that difference there, and then we're going to divide it by that difference there. All right, so that is 74,000, so 74,000, 74,000 difference, and this difference is 20. All right, now this is doable without a calculator. We just set it up over here, 74, oops, missed off the 4, rub that out, cross that out, 74, 0, 0, 0, 74,000 over 20. Now straight away, we can just knock a 0 off. We can divide both numbers by 10, which means we've got 7,400 divided by 2. And that means that we do, we can do 74 divided by 2 and then put the 2 zeros on to our answer. So 74 divided by 2 is 37, and then 0, 0. So 3,700 litres per hour is the answer to that question. All right, I hope that makes perfect sense to you. All right, it's just finding the gradient. Now I'm going to zoom out of that one, if I can. There we go, and I'm going to move myself over so we can see the third and final question. Now this one is one where we've got to match some things up. All right, we've got a container. It's filled at a constant rate, just like the pool was being filled at a constant rate. And that pool was a perfect cuboid, and it would just be filling up with our directly proportional graph, basically, is what this is. All right, but it doesn't start at 0, 0 because there was already some water in that pool. But in this example, it's going in a constant rate, but these are different shaped containers. Match the container with the graph that shows the height of the liquid in the container over time. So we've got to look for what graphs match what. All right, so first of all, I think the easiest one to look at there is C. Definitely matches with this directly proportional graph. Right, if there was no water in there to begin with, fills up a constant rate, it's not deviating at all, it's not going up or down, it's a uniform shape, so that one must match up with that one. So you just join those two things together with a line like that. If you want to put the arrows on the end, you can. All right. Now let's look at A. All right. Now the water is going to go in here. The container is going to start to fill up, and it's going to look like it's filling up quite quickly, and then it's going to slow down. So what we need is a graph that starts off steep and then tails off and goes a little bit slowly. Right. And that's that one there. It starts off quite steep and then it starts to slow. All right. And that's what this graph is telling us. That's the story it's telling us. All right, so I can match A up with the one that's over here. All right, B, well, we've got, it's going to look like it's going to be going quite slow. It's going to take a while, take a while, take a while, take a while, and then it's going to just like speed up until we get to the top, because there's less space here to fill at the top of this than there is at the bottom. All right, so what we're looking for is one that starts off slowly and then increases. And you see the steeper the curve, right, that's showing us it's filling up more quickly. All right, so there we go. That one matches that one, and then obviously this one has to match this one because it's the only one left, right? But this one you could see it's got that kind of slow start, then it speeds up in the middle, then it slows down again, which makes sense for this container because it's got slow start, speed up in the middle, and then slows down again. All right, and that's kind of what the stories are for each one of those graphs that's telling us what container it matches. All right. Now, I hope all of that makes sense to you. Please do click the link in the description to practice this sort of thing. Yeah, and if you weren't sure about finding the gradient, go back to the finding the gradient video and watch that one. All right, I hope you've all had a lovely time watching this one. I hope you have a lovely rest of your day, and you take care of yourselves. Thanks for watching. Bye-bye.